Hello. Okay, so we're going to talk about the visible spectrum. Okay. So make sure that you are taking down notes. You are writing with me. Oh gosh. Really we're talking about the visible spectrum and the electromagnetic spectrum. But let's just go on and get started. Okay, so light waves are fast, right? They are faster than sound. They don't need anything to travel off of. They can travel off of themselves. They don't need matter like sound does. So the light waves, let's write that. They are fast. There's 186,000 meters per second. Okay, that's how fast they are. It takes sunlight. That was a loud bird. Sunlight travels to Earth in 8.5 minutes. But that's 93 million miles away. So, I mean, that is, let me make sure I said that. Yeah, 93 million miles away. So that's fast. You know, if you think about it, 93 million miles, you know, that's a long, like it takes, 60 minutes to travel or an hour to travel 60 miles if you're going, pretty fast. So that's crazy. Okay, so light has magnetic and electric fields. Okay, so this is called electromagnetic, make sure I don't misspell it, it's a long word, radiation. Okay, so this is it's how light waves are broken up. Okay. Now, out of that, the visible spectrum is the only part of a light wave that we can see. There are a lot of different light waves, and we use them for different things like X-rays and microwaves, but we can only see the visible spectrum. We can only see white light that's broken up into colors. But we cannot see infrared, ultraviolet. We can't see that light, okay? We just can't see it. So let's make a chart. Okay, and this is going to be the electromagnetic spectrum. Okay. So I'm just going to start. And we'll start with radio waves, microwaves, and then infrared. Then we've got the visible spectrum. I'm just going to abbreviate that. Then we'll have ultraviolet, like sun, okay, sunshine. Then we have X-rays. Then we have gamma ray. Okay. So out of this whole spectrum of light waves, we can only see just a small portion. Okay. So when you're all the way over here, we have frequency, just like we have frequency with sound waves. We have frequency with light waves. So radio waves, have a pretty long wavelength, and then it gets a little bit shorter as you go. Okay, and then all right, that's not the best, but you get the point. So this is at the very beginning here. It is low frequency. And it is a long wavelength. So from like here to here, that's a longer wavelength than from here to here. This one's sort of messed up. I didn't do a very good job. But over here is longer. Over here is higher. These are lower energy as well. Okay. Over here is high frequency, which means they occur more often. Running out of space. And then this is a short wavelength. Okay. And high energy. Okay. So X-rays and gamma rays have a higher frequency, shorter wavelength because they're closer together. Over here, the wavelength is longer because they're further apart. Okay, this is lower energy. Now, inside the visible spectrum, each light that we see has its own wavelength, and we'll talk about that in just a second. So, yeah, okay, so that's our spectrum, and you'll see that on a Google slide that we'll do here in a second. I think it's today. You will do a Google slide that is similar to this. All right, so each in the visible spectrum, let's do. Okay, in the visible spectrum, so like right here. Each color has its own wavelength that we see. And they're all different. So like red is the longest. Violet is the shortest. Red is the longest wavelength. Okay. And violet is the shortest. Okay. We can remember Roy G. Biv. And this just makes up the rainbows, the colors of the rainbow. Okay. Roy G. Biv. So we have red, orange, yellow, green, blue, indigo, violet. Okay. All right. And if you notice, sometimes now they've taken indigo out. Indigo, it's indigo. But I still say indigo. Because if you do the acronym wouldn't work, Roy G. Biv, it would just be Roy G. Biv. So you have to have the I. So we keep indigo in there. So we can remember the order of the rainbow: red, orange, yellow, green, blue, indigo, violet. Indigo is just a different, it's sort of like blue and violet mixed together, which is why they've taken it out. It didn't stand alone enough. But we have red, and that is why red is the longest, because it's on the outside. Okay, it's the longest wavelength. Red, orange, yellow, green, blue. Okay, and I'm just gonna put purple in there for violet because I do not have an indigo. Okay, all right. So the rainbow right there. Red is the longest, violet is the shortest. Okay. All right. That is it for science for these notes for today. And next time we are going to talk about refraction, reflection. So some big terms coming up next week. Okay. All right. Let me know if you have any questions. Bye.